Welcome. I am Professor J. N. Mandal, Department of Civil Engineering, Indian Institute of Technology, Bombay. Today, I will discuss the field density test using the core cutter method. How you can determine the field density, and this field density is very important. This is much more realistic test, and I will talk about more detail about the procedure and how you will perform the test in the field. So, fourth number, that what is the weight of sand field in the cone. So, this is weight of the sand field in the cone is designated as WC is equal to 445 gram. Then weight of sand field in pit alone, that is W of S will be equal to W of 3 minus W of C. So, this will be 2135 gram. Then weight of wet soil collected from pit, that is W is equal to 2532 gram. Then dye density of standard sand use. This is from step 8 of determining density of standard sand, that is gamma of sand is equal to 1.40 gram per cc. Now, you know that what should be the volume of the pit, that is V is equal to Ws divided by gamma of sand. That means Ws is equal to 2135. This is Ws is equal to 2135. This divided by gamma of sand, and gamma of sand is 1.40. So, 1.40. So, this will give the volume of the pit, okay, about 1525. This is cc. Then 9, weight density. Weight density of the soil, okay, that is gamma of m is equal to W divided by V. So, you know that W is 2532, this weight of the wet soil collected from the pit, 2532. So, we can write 2532, this divided by the volume. So, volume of the pit we determine that V is equal to 1525. So, you can write 1525. So, this will give the density about 1.66 gram per cc. And then you can calculate the moisture content. Moisture content of the soil, and that is in percentage. Let us say M is equal to 27.4%. So, you can calculate also this moisture content. Now, we can calculate the dye density of the soil, okay, which is designated as gamma of D. Gamma D is equal to gamma of M, this divided by 1 plus M divided by 100. So, this is gamma M, we just calculated 1.66, this divided by 1 plus M by 100. That means, if you calculate this, it will be the 127.4, 127.4, and this into 100. Okay. So, this will give you that density of the dye soil is about 1.30 gram per cc. Okay. Because here moisture content 27.54. So, you can calculate the dye density of the soil. And then you know that specific gravity of the soil, that is G is equal to 2.65. Okay. Now, you can calculate void ratio of the soil, that is E. So, E is equal to G of gamma W divided by gamma D minus 1. So, G is, I mentioned that 2.65. So, this is 2.65, that into 1, okay, and that divided by gamma D already we have calculated, that is 1.30, okay, 1.30 minus 1. So, this will give you about 1.038. Okay. This is the void ratio, 1.038. Then you calculate the porosity, and that is designated as N, and unit is percentage, that is E divided by 1 plus E into 100. So, E value you know 1.038, So, 1.038, this divided by 1 plus E, that means 2.038, this into 100. So, this will be about 50.92%. Then degree of saturation, and that is in defined as S percentage, that will be equal to G into M divided by E into 100. So, we know G is 2.65 and M already we have earlier the calculated, that is 27.4. This is M is 27.4. So, you can write 27.4 and this divided by E. Okay, E is 1.038. 1.038. So, this into 100. So, this will give 69.95%. So, you can calculate the degree of saturation. So, knowing this, how to calculate the void ratio, porosity, degree of saturation and the dye density and the moisture content from this test. Repeat. Remove the side material and take out the filled up core cutter gently. Properly trim the top and the bottom surfaces and wet the material. Next, keep 2 moisture can along with the wet soil for moisture content determination. From the step 4 and 1, find out the weight of the soil in the cutter. Then weight density and the dye density of the soil can be calculated as usual. I will show you that equipment what we use for this test. So, this is the test apparatus for core cutter method. So, here this is the cutter, this part is the cutter and this is 106 millimeter diameter and this is 100 millimeter diameter inside and this height is 127.4 millimeter. This is the cutter and the top of the cutter there is a dolly, this is the dolly and which is from here to here is 25 millimeter. And then this is the rammer, this is rammer. So, rammer is 75 millimeter from here to here and here to drop, this is about 900 millimeter. So, this is the rammer here to insert it into the soil. Okay. Next again I will show you some more about this procedure for the core cutter method and this is for determination of the field density by core cutter method. So, this is the core cutter, and then this is the what I showed you, that is the rammer, and then you are to insert this core cutter into the in situ soil by the aid of this rammer. You can see here rammer is inserting this core cutter, it is here, and then you can take out the soil around this core cutter, and then you take out this cutter, and then you trim it, the top and the bottom. Okay. So, this way you can collect the specimen or soil sample, okay, for the determination of field density by core cutter method. So, this I will now show you some specimen calculation. So, this is the specimen calculation for field density test using core cutter. So, what we can write, that first of all, that you measure the height of the cutter, and that is 12.5 centimeter. Then initial diameter of the cutter is 10.0 centimeter. Now, you know volume of the cutter, and that is VV is equal to 981.7 cc. Now, weight of the cutter, that is WC is equal to 1274 gram. Now, you take the weight of the soil, plus the cutter. Okay, just say W1 is equal to 2884 gram. Now, you can calculate weight of the soil, that is W is equal to W1 minus WC. So, weight of the soil will be this is W1 minus this is WC. Okay. So, W1 is 2884 minus 12, this is 7 of 4. So, you can have this value is about 1610 gram. Okay. Then you can calculate the weight density of the soil. So, that is gamma of M is equal to W this divided by V of B. So, W is 1610 and that divided by this is BB, that means volume of the carter BB, this, that means 981.7. So, this will be equal to 1.64, okay, gram per cc. So, you know that moisture content of the soil, moisture content of the soil, that is M is equal to 28.1%. So, you know that how to determine the moisture content of the soil. Next, you can calculate dye density of the soil. That means gamma of D is equal to gamma of M divided by 1 plus M divided by 100. So, this will be gamma of M, okay, that is 1.61. This divided by this will be 128.1 into 100. So, this is 1.28, that is gram per cc. So, gamma is the weight density of the soil. So, 10 you can calculate the void ratio of the soil, void ratio of the soil, that is E is equal to G of gamma W divided by gamma D minus 1. That means 2.65 G, this is 1, this divided by gamma D is 1.28, this is gamma D 1.28, gamma W 1 and G you know 2.65. So, this minus 1, this will be equal to 1.07. So, void ratio is 1.07. Now, you can calculate the porosity, that is N and that is in percentage. That means, this is equal to E divided by 1 plus E into 100. So, this is 1.07, that is E divided by 1 plus E means 2.07 into 100. So, this will give that porosity about 51.69%. Next, you can calculate the degree of saturation, that is S in percentage. So, this will be equal to G into M divided by E into 100. So, this is G is 2.65 and M is the moisture content, you know, I have shown you 28.1. This I have shown you earlier that moisture content M 28.1. So, this is 28.1. So, 28.1, this divided by E. E is your 1.07. So, 1.07 into 100. So, this degree of saturation, it will be about 69.59 this percentage. So, from this core cutter method field density, you can determine that what should be the dye density of the soil, what should be the Void ratio, that is very important. Void ratio, you can calculate the porosity, you can calculate the degree of saturation. These are all the important parameter for the calculation of the field density, and it is the realistic test because you are performing the field density into the test. So, from this field density test using the core cutter method, so you can determine what should be the field density of the soil specimen. Apart from the field density, you can also determine that what should be the moisture content of the soil, what should be the specific gravity, what will be that porosity and the dye density, moist density and the void ratio and the degree of saturation. And this field density test is important. You are having some realistic value for the soil, and this test is generally performed on the field. So, you can determine all other parameters. Thank you.